So this section is on arcs and chords within your circle. Okay, so again, chapter 10 is all about circles. Now we're just focusing on certain arcs and certain chords given different types of theorems. Your quiz for chapter 10 will be on Friday. Okay, chapter 10 quiz is on Friday. It's just on 3 sections. Okay, so first section was just looking at the circumference and different parts of your circle. Okay, so you will need to look back at those circumference formulas. 10.2 had to do with arc measure and arc length. So we did 2 different note sheets on that one. So arc measure is from your central angle. Arc length is that formula that we used. It's part of the circumference. And then our last section here is on arcs and chords. So we're going to go through each of these theorems and then do some examples from each. So the first one we have says equal chords cut equal arcs. So if I have arc RS congruent to arc TB. So I know RS and TB are congruent to each other, right? I can mark that with this as well. Okay, so those 2 arcs are congruent. That means that the chord that cuts through that arc, those chords are also congruent to each other. Okay, so if R, S, and TV are congruent, those arcs, then so are those chords. Okay. And vice versa. So if you know that those chords that cut through those arcs are congruent to each other, then those arcs must be congruent to each other. Okay, so we're going to do a couple examples of this. This first one. In my picture, SR is congruent to ST, correct? That means that the arcs that those chords cut through, have to be congruent as well. Okay, so arc RS would be congruent to arc TS. Well, if arc SR is labeled as X, ST would also be X. And then what do all of your arcs together have to add to be? 360. So I can add all 3 and set it equal to 360. Okay, so I have X plus X, so I have 2X plus 64 equals 360. So subtract 64. And then divide by 2. X is 148. Okay. So again, that was using those congruent chords and congruent arcs. Number 2. My picture shows that chord JK and LM are both 4. So since they're both the same measure, they are congruent. So now the arcs that they intercept have to be congruent. So what does X have to be?
82.
Okay. Then number 3, last one in this section. We're given arc CD is congruent to arc AB by these dashes. So that means their chords are congruent. So how can I solve for X? Set them equal. So we have 2X plus 3 is equal to 8X. Okay, so since those chords are congruent, we can set them equal. So subtract 2x from both sides. So we have 3 equals 6x. Divide by 6. And x is equal to 1/2, or you can say 0.5. Okay, questions on our first property here with our chords and arcs? All right, our second property says if a diameter, or this could be a radius, okay, it doesn't have to be the diameter, it could be the radius as well, is perpendicular. Okay, so again, the symbol means perpendicular. To a chord, then it bisects the chord and its arc. Okay, so if we know, looking at our picture here, if we know that WZ is perpendicular to AB, okay, that's why they form that 90-degree angle there. Same thing with WZ and RS, forms that 90-degree angle there, so they are perpendicular. Match up my colors here. Then I can say that that line WZ bisects AB. Okay, so we have AX is congruent to XB. Okay, so it splits it into two congruent pieces. It does the same thing with your arcs. Okay, so that means arc AW is congruent to arc WB. Okay, and that's what it says down here. Okay, so this is true when your diameter or your radius is perpendicular to your chord. Okay, then it splits that chord into two equal pieces as well as that arc. Okay, so it's kind of like that midpoint. It splits it into two. So on the right, we do have some examples. So in circle P, the radius is 13. Okay, so a radius is 13. And RS, so this entire length here, is 24. We want to find each measure. So number 4, we want to find RT. Well, since QP is perpendicular to that chord, what do I know about RT and TS? They're congruent, and you're correct, Alyssa, they are 12. Okay, so since those are congruent and I knew RS was 24, we just have to divide that by 2, and RT is 12. Okay, next I want to find PT. Okay, PT is this little tiny section right here between your center point and where it's perpendicular. Okay, this is where I want to use the radius is 13. So when you see problems like this with that perpendicular or 90-degree angle marker, what I want you to do is go from your center point and connect to your chord. Okay, that length that I just drew in, what is that called? The radius. Okay, so I just drew in a radius, and I know the radius is 13. So I can label that length 13. Now since this angle right here is 90, that means all 4 of these are 90 degrees. So to find this missing little piece right here, I have a right triangle. What do I use if I have a right triangle and I'm missing one side length? The Pythagorean theorem, yes. Okay, so I'm missing one of the legs of that right triangle. And my hypotenuse, or my C value in the Pythagorean theorem, is 13. Okay, so I'd have x squared plus 12 squared equals 13 squared.
Wow.
Okay, so I have x squared plus 144 equals 169. Subtract 144 and take the square root of both sides. So PT would be 5. Okay? Then, number 6. Okay, number 6, we're looking for T to Q, right? Well, I know what P to T is, right? We just found that it was 5. What's P to Q?
That's 13.
That's 13. Why is it 13?
That's radius.
Because it's a radius. So if I know P to Q and I know P to T, how do I find T to Q? Don't add them together. You subtract.
Subtract 5.
You take the entire length of Q to P, 13, subtract the part you know, which is 5. So TQ is 8. You were somewhat close.
You're pretty close with the dividing part.
Okay. Questions on those 3 problems. So on these types of problems, you will have to use the Pythagorean theorem. All right, I want you guys to do 7, 8, and 9.
Oh, I got you.
7, 8, 9. It's very similar to the 4, 5, and 6. Okay, so use your picture. Label the parts. You can do it.
I'm going to do the easy one first.
So A is 12, right there. If I write that correctly, probably
The
not.
diameter is 12.
What? Your diameter is 12. So what's your radius if your diameter is 12?
6. Got it. AF.
It's right there. Huh? Probably was, yeah. I just wasn't doing this computer. I have not written this except for when I was suspended. All right.
Would that be 90?
So you put this little line here.
My friend was like,
this.
yeah, I used to do cartwheels.
Which
I
one?
did the splits. I'm like,
I used to do cartwheels.
So, 6 is that one.
Not
I remember that. I still
All right. That's,
Here's my
From
so you need
C
the
to D is
Pythagorean
90.
theorem.
So from D to E.
My cat did a somersault in the middle of our giant kitchen. And mom's like, oh, Lisa, can you do that? I'm like,
Is this for your Are my AirPods at 75 or your case is at 5%?
Yep. From A to D.
Oh, stupid. Flexing.
my sister's like, yeah, I don't speak bro.
So what's the length from A to D?
The wire. I'm like, are you stupid?
I lost mine already once and then like
Dude, yours charged while you're listening to
Yeah.
music. That's how good it is.
What is
But the good thing
I
is
have
I
this
good thing about the AirPods is that you can charge it, but you have to have Bluetooth to charge your phone.
That's why you get that little double.
CD is a split.
I'm not spending $40 on that little.
It's $3.
I don't afford $3. I pay
But yet you can afford those. Are you?
My parents pay for those.
Of course they did. My father always said you're going towards.
This was talking about the arc. So this is here 90, right? The one from this part.
And we're
Green light.
Oh, yeah.
But you're going towards like the.
I'm still gonna.
Oh my god.
I have, like, on the same road as, like, Adams Road.
Okay, you're coming.
Okay, so, like,
Okay, you're going.
on the same road as Subway.
Like the main road from.
Like 23. Highway 23.
Yeah, and you go around like the little curve, you go past the police department. Yeah, and you go down that way, and then you come up, and there's a curve.
Then the stop sign. Yeah.
John, you turn around this way. Like, this way, you go that way, it's Adams Road, which is
It's on the, so it's like,
No.
it's on the, so this is the road with Adams Road, and then there's the road before it. It's the road before it.
Yes.
Yeah, I got it.
So like, you,
The curve.
Ross's house is right
And
here.
you go, no, it's not. There's a stop and a road right here.
I think that-
Two.
This one is like this one. So draw in your radius. Okay, what's your radius? But, okay, what would that be?
Oh, yeah, I know.
All right, so looking at number 7, when you guys read through the directions, you need to label your picture. Shh. Stop talking, pay attention now, please. You need to label your picture when you read through your directions. So the diameter is 12, right? So from B to E is 12. What does that make your radius? 6. Okay? CD, from point C to point D is 8. Well, I know this is perpendicular to that chord. So these are congruent, meaning it splits it in half. So each of those would be 4. Then I have the measure of arc CD. So from C all the way around to D is 90. Okay? In number 7, I'm trying to find the measure of arc DE. So that's this piece right here. Well, since this diameter is perpendicular to that chord, your arcs get split in half as well. So arc DE would be 45. Okay? Then number 8, we're finding FD. Well, because of my directions, I already labeled what FD was. Okay? That is 4. Since CD was 8, 8 divided by 2, 4. Last one, number 9, trying to find AF. Okay, so again, when you have problems like this one, you are probably going to have to use the Pythagorean theorem. So you want to draw in that right triangle. So I'm going to go from the center point to one of my points on my chord and draw that in, because I know what the radius length is. Okay, that radius is 6. Okay, so from A to D also has to be 6. So now I've made this right triangle within my problem. I know this side is 4, this side is 6, and I can find that remaining side on the top there. So we have 4 squared plus x squared equals 6 squared, which is 16 plus x squared equals 36. Subtract 16. And then take the square root of both sides. And I get that side to be about 4.5. Okay, so if you see problems like this, where you're finding one of those smaller pieces within your circle, you are probably going to have to use the Pythagorean theorem if there's that right angle there. Okay, something to keep in mind. Questions on that? All right, the third one is very similar to the one we just did. So it says the perpendicular bisector of a chord is a diameter or a radius of the circle. So it's literally the same thing, just backwards. Okay? So if you have the perpendicular bisector, so we know that it hits that chord at a perpendicular, so 90 degrees, and it bisects that chord into 2 congruent pieces. Then it has to be a radius or a diameter. It has to go through the center of that circle. Okay? It won't be a second chord going through that chord. It has to go through the center point. That's what this one is saying. Okay, so looking at our examples to the right, in circle P, so our circle at the right, JK, that length is 10. And arc JK is 134. Right? Since this is perpendicular and a diameter, what do I know about these pieces? They're the same. If JK is 10, JQ would be 5 and QK would be 5. Now what about my arc? If my arc from J to K is 134, each of my smaller arcs would be 67. So in number 10, the measure of arc JL, we already found, using our directions, was 67. Okay? Next, I want the length of PQ. Okay, so we're looking for this length here. What should I do to find that? Yep, okay. So I could draw it over to J. I'm going to draw it here because it's going to look a little bit nicer, but you could draw it over to J too. No, you're still right. Okay, so I drew in my right triangle. What's the length from P to K? Six.
Where did you get the 6?
Right there. Diameter.
P to M is 6. All of your radii are the same in a circle. So since from P to M is 6, P to K is also 6. Okay, so now I have 2 sides of this right triangle. I can find that third side, P to Q, using the Pythagorean theorem. So we have 5 squared plus x squared equals 6 squared. So I have 25 plus x squared equals 36. Subtract 25 from each side. Get x squared equals 11. Then take the square root of both sides. That side length I got to be about 3.3. All right, questions on that property with our chords and arcs? All right, then the last property we're going through, number 4, says two chords are congruent if and only if they're equidistant from the center of a circle. Okay, so two chords are congruent if they are equidistant. They're equidistant from the center of a circle. So, in my circle below here, if I know that segment XO is congruent to segment OY, okay, so if I know these two segments are congruent or the same length, then I can say my chords that they intersect are congruent. So I can say AB is congruent to RS. Okay? See if my highlighters work here with this color. So if I have these segments, can you still see them? Yeah. Okay, so these segments, congruent. Then my chords that are equidistant from the center, AB and RS, are congruent. Okay, the opposite is also true. So now this time, if I have segment AB congruent to segment RS, so this time my pink ones, if I know those two chords are congruent, then I can say that my two pieces, XO and OY, are also congruent. Okay, so they're the same distance from that center point. So we're going to go over examples of this one as well. Number 12, in circle R, okay, TS, that whole length there is 21. And UV is 3x. And we want to solve for x. Well, I know that both of those chords are the same distance from the center of that circle because they're both 6. Since they're both the same distance from the center of that circle, they have to be equal to each other. Okay, so I can set 3x equal to 21. So x would be 7.
You know how I remember that? What? I remember 7 and 21 together is 3. I don't know why. I don't know how.
I would just know it because of football.
Okay, so that was number 12. Number 13, in circle Q, CD, so this length right here is congruent to CB, and GQ is equal to x plus 5, and EQ is 3x minus 6. Well, if I know that my chords are congruent, Okay, so those two chords are congruent. They're the same distance from the center, so that distance has to be equal as well. Okay, so that means GQ and QE are congruent to each other, so we can set them equal. Okay, so subtract x, add 6, divide by 2, and x is equal to 5.5. Okay, last one. Shh. Hey, we're quiet, please. I'm not done yet. Number 14 in circle J, you have GH is 9 and KL is 4x plus 1. Since RJ and JS are both 5, they are congruent to each other. So those chords have to also be congruent to each other. So we can set 4x plus 1 equal to 9. So I'll subtract 1 from both sides. Then divide by 4 to get x is equal to 2.